Alright, in this investigation, we're going to actually take something very simple and make it complicated. But then we're going to use that idea to take something complicated and make it simple. So we're going to start with 7 squared. We know that 7 times 7 equals 49. But we're actually going to break down that 7 and make it 3 plus 4 and use a box diagram to work out 3 plus 4 to the second power. So along the top I have 3 plus 4 because that equals 7, and along the side I have 3 plus 4 because that equals 7. And then we're going to use these 4 boxes to do 4 multiplication products. 3 times 3 is 9, 3 times 4 is 12, 4 times 3 is 12, and 4 times 4 is 16. Now when we add these 4 products together, 9 plus 12 plus 12 plus 16, we get 49. So we can use box diagrams to help us multiply. In part 2, let's take a look at one of these and work it out together. We'll do D together. Alright, 20 plus 5 to the second power. For larger numbers, feel free to use the calculator to help you. 20 plus 5, that equals 25. And 25 squared, or 25 times 25, equals 625. So we already know the answer here equals 625. But let's practice working out this multiplication problem using our box diagram. So here's how we do it. Across the top we write 20 plus 5, and across the side we'll write 20 plus 5. Now for each box we do a multiplication problem. 20 times 20, 20 times 5, 5 times 20, and 5 times 5. Now we take those 4 products and we add them, because we're finding the total area of the rectangle. And to find the total area, we will add the smaller areas. And sure enough, 400 plus 100 plus 100 plus 25 does equal 625. We can actually use subtraction with these problems also, and that will involve negative numbers. So notice, back to our 7 squared equals 49 problem, instead of doing 3 plus 4 for 7, we could do 10 minus 3. And then we end up with products of 100, negative 30, and positive 9. And when we add those together, sure enough, we still get 49. All right, let's practice one with subtraction. We'll do letter D. 50 minus 3 to the second power. Pull up our calculator to help us clear off the old answer here. All right, 50 minus 3, we know that equals 47. So let's calculate 47 times 47. All right, so we know that the answer will be 2,209. Let's work that out with the rectangle diagram though. So across the top we'll write 50 minus 3. Across the side we'll write 50 minus 3. I like to write the subtraction sign in front of the 3 because we're going to be treating that 3 like a negative 3. All right, 50 times 50 is 2,500. 50 times negative 3. Negative 3 times 50. And negative 3 times negative 3. All right, now we'll find the sum of those products to figure out the total area of our rectangle here. All right, let's check it. So we have 2,500 minus 150 minus another 150, and we need to add 9 more, and we get 2,209. We can use this same idea to square expressions with variables in them. Let's take a look at letter D. All right, x minus 13 squared. Now we're going to resist the temptation to just distribute that exponent of 2. Because let's see what happens when we really multiply x minus 13 times x minus 13. Right, across the top we'll have x minus 13. Multiply that by x minus 13. So we multiply x times x. x times negative 13, then negative 13 times x, and negative 13 times negative 13 is positive 169. Now when we add these four products together, we have different types of terms. Here we have an x squared term, and we have some x terms, and then we have a constant term. All right, so we're going to, since we're adding these areas together, we are actually going to be combining like terms here. So we're combining the two terms that just have x in them. And negative 13x minus 13x equals negative 26x. So x minus 13 to the second power will equal x squared minus 26x plus 169. A lot of people find results like this a little surprising. A lot of people leave out this middle term here, the negative 26x, and just say it's x squared plus 169. But we need to remember that x minus 13 to the second power equals x minus 13 times x minus 13. Another way to think about multiplying two binomials like this is to distribute the x to both pieces in the second binomial, and then distribute the negative 13 to both pieces in the second binomial. And when we do that, we're actually doing four multiplication problems. In fact, they are the exact same multiplication problems we did down here. And when we combine the x terms, the negative 13x plus the negative 13x, those don't cancel each other out. They make negative 26x. So be really, really careful anytime you are squaring a binomial. Like the answer for C here is not going to be x squared plus 121. There's going to be a middle term there. So be careful, work it out, you'll have a middle term. Soon, once you've worked out enough of these, you will see a pattern emerge that will make these easier to multiply quickly. Okay, one final puzzle here. Let's say we're starting with part of the box diagram. We know that one corner is x squared and another corner is 9. We're trying to figure out what binomial we must be squaring to end up with these parts in the rectangular diagram. So when we set up our box diagram, we know to get x squared it must be x times x. And to get 9, it could be 3 times 3. Now we can fill in the rest of the diagram. We have 3 times x is 3x, and x times 3 is 3x. It turns out we were squaring x plus 3. I hope these tips have been helpful. Signing off.